Smallpox is one that we have eradicated in the wild. But of all the viruses on Earth, that's one of the scariest ones to me because that has killed more humans than any other pathogen that we're aware of in human history.
Wow.
In fact, when we tried to eradicate smallpox, it was an effort where we actually worked with the Soviet Union. Despite the Cold War, we partnered with the Soviet Union to get rid of this thing. That's how bad it was. Nobody wanted it. Them, us, everybody. It was a worldwide effort because it's believed that this thing has killed 2 billion humans in the history of humankind. Hello, everyone. I'm Dr. Christopher Stobart, Associate Professor of Biology at Butler University, and you're listening to the Public Health Insight Podcast.
You're listening to the Public Health Insight Podcast, your go-to space for all things public health and global health, from the Sustainable Development Goals to the social determinants of health, as well as interesting dialogues about the diverse career opportunities that exist in these fields. Remember to subscribe to the podcast and leave us a rating on Apple Podcasts and Spotify so other people like you can benefit from our content. The human body is home to a staggering array of viruses, collectively known as the virome. While most are harmless, and some might even be beneficial, scientists have only begun to scratch the surface. Over 200 species are known to infect humans, but the true number is likely to be way higher, with new viruses being discovered each year. From PHI Media, I'm Gordon Thane, and in this episode, we spend some time with Dr. Stobart as we journey into the hidden world of infectious disease, how viruses evolve, how they leap from animals to humans, and why, even with all the scientific knowledge that we have, they remain one of humanity's greatest challenges. Do we know how many human viruses are out there or have been out there? Is there a way to even estimate that? What are we looking at in terms of numbers?
There's no way to know how many viruses, and what I can tell you is some of the studies have shown how many viruses do we on average have in us at a given time that are human viruses. Probably at least a dozen that are in us or on us at some time. If you've ever gotten a herpes virus, and not all herpes viruses are those herpes viruses.
Right.
There's actually 8 main herpes viruses. If you've gotten a herpes virus, you have it for life. It's embedded in your neurons and it's hiding out in your neurons. So we carry viruses with us. We pick them up transiently from eating something, and they hang out and they replicate, and they may or may not go away. So there is this collection of viruses that are just kind of part of who we are. That's borrowing language from the human microbiome, because there's also a lot of bacteria that live on us or in us.
Right.
But then beyond that, if we think how many viruses in nature out there could infect humans, there's no way for us to be able to answer that question, because also there might be a possibility that viruses infect animals, might be able to infect us to some degree, may not cause full-blown disease, may not be able to cause severe harm, but there might be some crossover there. And then there's also these adaptations. If it's like COVID-19 called the variants. Well, are the variants the same virus or are they new viruses? How do you count that? Because I can tell you, based on the stats and the science, there's been dozens and dozens of variants since 2020.
Right.
So are they all the same virus?
Right,
or are they just evolved versions of the same virus? Or are they different viruses? It's hard to quantify. But what I can tell you is that viruses want to replicate. Their whole goal in life, if we're trying to anthropomorphize what they are, is to replicate and spread. So as long as there are people and there are opportunities for them to infect us and replicate and spread, they're going to continue to be there. And unfortunately, there's nothing we can do about that.
Many of the world's most devastating outbreaks, like Ebola, HIV, and COVID-19, began when viruses jumped from animals to humans. This process is called zoonosis. And it's a stark reminder that our health is deeply intertwined with the natural world. As human activity pushes further into wild habitats, the risk of new pandemics only increases.
They're going to continue to infect and spread. If we understand the biology behind what they're doing, we might be able to limit that spread. We might be able to limit the disease they cause. But to eliminate all viruses infecting humans is not something that is possible with modern science, not even close.
You mentioned that some transmission might take place with animals. Obviously, with zoonosis, can jump over to humans.
Yep.
Like It's obvious to say a human virus is one that can infect humans.
Right.
But what does the virus need to be able to do that? Like, what are the characteristics of the virus that it needs to have to be a threat directly to humans?
Yeah, when we talk about pathogenic viruses, and usually when people talk about viruses, we're talking about those that cause disease, viruses.
Right,
There are
pathogenic.
different challenges that the virus has to overcome. One is gain access to us. If we never come in contact with it, it's not a problem. You got to gain access. The second part is you got to find the special cells or tissues in the human body that you can actually infect. Virus has to get inside of our cells. It can't replicate if it can't get inside of our cells. And this is important for the vaccine side, so we'll come back to it later. But it has to find those cells or tissues. So there's that barrier of, can you get to where you need to get in the human body without being killed by the immune system or some other physical chemical barriers that might exist? Once you get inside the cell, you need to be able to replicate without being detected, right? Because the immune system's trying to kill you. If you're a virus, you're constantly under assault by the immune system, right? And then lastly, you need to cause damage. That is, cause disease. So those are kind of these 4 layers that a virus has to overcome to become an infectious disease in humans. Those viruses in other animals, often the challenge is that they've evolved and adapted to infect and spread in that animal really well. But in evolving towards that animal, you're often evolving away from infecting other animals. And so when we see viruses jump from, say, primates or from birds or from pigs to humans, right? Often they don't infect very well initially. They don't spread very well initially. They have to adapt to us, actually. And there is this adaptation period. And I know I keep going back to COVID, but everyone's lived through COVID. Everyone's supposed to know a little bit about coronaviruses now. When this COVID first jumped into humans, the disease mortality rate was much higher than it is now. Part of that is due to we didn't know what we were doing, but also because that virus came into us, it hadn't yet adapted for spread. It was just trying to survive. And in doing so, there was a lot of collateral damage. A lot of people got really, really sick. It's not a benefit to a virus to make you sick.
Right.
And this is, I know it's hard to believe,
Right.
but if you get sick and die within a day, then that's lost opportunity for the virus to spread to somebody else, right? So it's better for the virus to make you less sick and keep you upright to optimize spread. And so that virus, COVID, went through all these variants because it's trying to spread better in humans. It's trying to get from person to person. And the virus that figures out how to tweak its genome to spread better outcompetes the previous generation, which is why we had variant on variant. But jumping from an animal to a human is not easy, right? Because you have to adapt to a new organism and the new challenges and the new issues that arise.
Just when you think it couldn't get more complicated, I remember from my classes about RNA viruses, there's DNA viruses, double-stranded, single-stranded, positive sense, negative. How can you simplify the concepts around the different types of viruses and why it matters what they are? Like, beyond being all scientific geeking out about the different classifications of viruses, why is it important to know the different types?
Yeah, so if you're going to target something in a virus or a bacteria, if you want to go after a pathogen, you want to kill it. You need to find something to target that we don't have. Because if you target the same thing that we have, that they have, then you're hurting us and them.
Right.
We call this selective toxicity. We need something that's toxic against the pathogen, but not us. Now, the genomes of viruses, the thing that encodes the machinery to make new viruses, can be made out of DNA, which we have. It can be made out of RNA, which we have RNAs, but we don't have genomes made out of RNA. It could be single strands, double stranded, all different flavors and varieties. But the one thing that's unique that viruses have to do is they have to copy their genomes. And if they have a genome that we don't have, then they have to have machinery that we don't have. And if you could target that machinery, block the machinery, then you're targeting something that won't hurt us, but will hurt them a lot. And so that's why it's important to understand, what does the virus look like in terms of its genome? What does it look like in terms of structure? Is there some weak spots that they have that we don't have that we can target and block them? Viruses are kind of a jack of all trades. They have a bunch of different things going on. They have to infect our cells. They have to hijack our cells. They need to get everything they can out of our cells. But they have to still follow some rules. They still have to copy their genome. They can't get around that. They still have to make proteins to build structure. They can't get around that. So if you can find those weak spots that the virus has that we don't have, that's where you want to go. And most meds today, antivirals today, are designed to target unique features that the virus has that we don't. So COVID, if you got put on Paxlovid, it targets a protein that helps the virus disassemble pieces and build its replication machine. We don't do that. We don't have a virus replication machine. You block this protein, virus is dead on arrival. And that's why it was targeted. A lot of people target the actual copy machine for the genome itself, which we call the polymerase. Go after that, boom, virus is dead. So when we look at the viruses, it's really important that we study and understand those features, the biology of the virus, because we can learn what those weak spots are, and that gives us an opportunity to target those features and actually develop therapeutics.
So I want to put a fun spin on this. I think that kangaroos are one of the weirdest types of animals I've ever seen. It just doesn't make sense to me how kangaroos exist. Of the viruses that you've studied, learned about, which one do you think was like, it's so weird how this virus operates?
Oh, there's a whole bunch of them.
They're all weird.
Yeah, no, they are. And each of them
Or
brings
interesting,
different things in. So I think some of the fun ones that are on the frontier or the wild west of virology are the really small guys. So for instance, probably a lot of your listeners have heard of hepatitis B, right? They've probably been vaccinated against hepatitis B. But I don't know if you know, but there's a hepatitis D. And you never hear about Hep D, but Hep D is a parasite of Hep B. In essence, it cannot go anywhere unless Hep B is there. So Hep D, it's a super, super small genome. It's like one gene. And what it does is it basically infects cells that already have Hep B, and it just hijacks all of Hep B's machinery. So it's like a parasite of a virus. So
but it's still a virus.
It's a virus, and we call it a satellite virus because it's like a satellite going around with other viruses, and it can't replicate and create new virus particles without Hep B being there. Now, why do we care? Well, when people get co-infected with B and D, there's a 20% mortality rate, right? It makes it a whole lot worse if you get Hep B and D. So like that's to me really interesting. Some of these bacteriophages, the ones that infect bacteria, are some of the most complex looking things on the planet. Imagine spider looking guys. You see pictures.
So they look like how they look in the drawings?
Is that how they look? Spiders. They attach to a bacteria and they drill through the cell wall of the bacteria and inject their genomes and then do their thing. Why does the bacteria have to have the most complicated looking viruses on the planet? I don't know, but they do. The largest viruses we've ever discovered on Earth infect algae. Who would have guessed the largest virus is infecting algae? And there's all kinds of these weird oddities. So hepatitis B, going back to that one, has a genome that's part DNA, part RNA. It's like it hasn't decided which one it wants to do. So it's a little bit of both.
Right.
And
that's interesting.
It breaks a lot of the rules. So there's a whole bunch of these things in the community where you learn, wow, that's a thing, that's a virus. That the virus is doing what, and it's kind of fun thinking about what's out there and how it works.
Measles is a case study in both the power and fragility of public health. Once declared eliminated in the United States in 2000, it has made a troubling comeback in recent years. What makes measles so formidable is its R0 value, or basic reproductive number, where a single infected person can spread the virus to 12 or even up to 18 others in a susceptible population, making it one of the most contagious diseases known. In 2023, the World Health Organization reported a 79% global increase in measles cases, fueled by, and some of the drivers behind that were declining vaccination rates and increased travel. One of the hottest topics now in terms of the world of virology, perhaps, and even public discourse, is these measles outbreaks that are happening in the US and some other countries as well. So before we get into the societal impact of measles, if we were to treat measles like a person, what would their origin story be? What's their day-to-day life? How do they go from place to place? Can you If we could break it down in simple terms, in terms of what measles
You
is.
want me
and where
to
it
you want
came
me to
from.
equate measles to a person?
Or just explain it in simple language. Like where did it come from? How long have we known about it? What it does? What makes it different from other ones?
Yeah,
That
measles
kind
has
of thing.
probably been in humans since humans have been humans. A lot of these viruses have adapted to spread in humans for thousands of years. And so it's not a new virus. It's been
Right.
around for a very long time. We've known about measles and it's been described in literature for hundreds of years through accounts of the lesions it creates and formation of these marks that it can produce. It's not that this is a new virus. It's actually an old virus.
Right. Right.
What it is, it's a very, very, very infectious respiratory virus. Okay. We know that, for instance, someone who has measles, if you're within about an 18-foot radius, you can infect other people.
18 foot.
18 feet. Yeah. So you want to talk about social distancing. Measles is one of the most infectious things on the planet. And in fact, up until COVID, some of the more recent variants, it was considered the most infectious virus that infected humans. So it's extremely infectious. When you get it, it will get in your body and it will spread systemically. So it's just going to get throughout your body. It doesn't stay in one location.
Right.
All right. And you get these little red spots, right? As an indication, you'll get these unique spots in your mouth called Koplik spots. There's a few hallmark signs of measles, but it can cause a really high fever. It can put the body under stress, and it can, in some cases, cause some severe organ impacts that can lead to mortality. And so it is a very scary virus. In the United States, if you look at the stats, even right now with modern technology, modern medicine, there are people dying from measles in the current outbreak. So it's not a virus that we want to mess with. It's certainly one that is scary from its ability to spread. There's been cases or counts of when there's been measles outbreaks, somebody on an airplane infecting 30 people, right? Just on one airplane. And you think of that and you say, okay, we've lived through COVID and the scares of spread and how well COVID spreads. Well, measles is the same level of potential for spread. It really can spread well if the population doesn't have the protections to block it and minimize that spread. I see measles, it's a scary virus. It doesn't have the really high mortality rate, but when you think of the number of people it infects, the social population concerns are big, right? Yeah, right now we're looking at in the U.S. this year about a 0.2% mortality rate. Okay, that doesn't sound too scary.
You kind of brush it off, carry on.
Yeah, it's about 1 in 500 people dying from it.
Right.
But if 1 million people in the United States got it because there was a widespread outbreak, we're talking now 2,000 people dying from measles.
Right.
So while, yes, on a one-off basis, it may not kill at the same rate as some of the more scary viruses you may have heard of, the impacts on society are huge. Right.
Imagine in a small community, you probably have to shut everything down. People can't go anywhere, and it's more disruptive beyond like being critically sick. Like there's some disruptions in your daily life for quite a while, going to work, going to school, right? That people miss out on days off because they can't go to work.
Yeah, and some of the communities in Texas, for instance, that have been impacted by the current measles outbreak, and in New Mexico, it shuts the town down because it's so infectious. If you're around anybody who has it, there's a high chance you can get it, especially the disease side if you've not been vaccinated. It's something to be worried about. I'm just giving you the facts. This thing is a very infectious virus. It can cause severe disease. We know about 13% of people who get infected right now get hospitalized for it. 1 in 8 are being hospitalized for measles infections. So this isn't something that's just a trivial virus. It's not just a cold and you're going to get it and be able to move on. If you're young or if you're old or your immune system is in the tank or you have an autoimmune disorder, this could be a very, very life-threatening pathogen. And so that's why the public health community is concerned. And also we know that the vaccination rates aren't where they need to be to prevent community-level spread in a lot of places. So it's ripe to take off, and I would guess that we're going to see a lot more measles cases before this thing's over.
All right, so we're going to go to vaccinations in a second, but before we go there, if I was to ask you what emerging or re-emerging viruses worry you the most, like that give you the most concern over the next 5-10 years, Is
Yep.
measles one of them? Do you have other things on your mind that you're concerned about based on the knowledge that you have?
I, up until recently, was a director of our new public health program, and we had some conversations in my epidemiology class about what is the future look like for pathogens and where should we be concerned. And I think one of the most important things to keep in mind is what is the societal impact, right, of these things. And I'm not trying to minimize those things that don't cause as much disease, but those big disruptors, the scary things that are out there that are hidden.
The fight against infectious disease is a race between scientific progress and societal will. Vaccines and antivirals have pushed life expectancy to historical highs, but misinformation and complacency threaten to undo decades of progress. As new viruses emerge and old ones resurface, the choices we make, individually and collectively, will shape the future of public health.
Right now, we're in an era where we're questioning whether vaccines do anything, and we're questioning whether these therapeutics, these meds that you're given to treat viruses, whether they do anything. And if we go back to an era where we remove the vaccines and the therapeutics, the life expectancy in the 1850s was still in the 30s and 40s. Reason why our life expectancy today is up in the 70s or low 80s in modern first world westernized countries is because of not just advances in medicine, but also because the scary things used to kill people, we have treatments and protection for. And when you remove those protections, so there's a whole bunch of them. Polio didn't used to be anything we'd ever hear about in the United States. But in the 1950s, when the first polio vaccine came out, that year, there was 50,000 kids paralyzed.
Oh, wow.
In the United States. It was a big paralytic polio outbreak in the United States. And the stories of kids being put into an iron lung. And if you don't know what an iron lung is, go look it up. It's scary. Because what happens is it will paralyze the neurons that allow you to breathe in and out. And so you need a machine that actually will make you breathe in and out, or you will die. And these kids were left in these machines for their entire lives, unable to breathe.
Wow.
Kids who couldn't walk. You know, FDR famously was in a wheelchair because he had polio as a kid, and he was paralyzed from the waist down. You know, this is a virus that we have protections for, we treat, and we've almost eradicated it.
Smallpox stands alone in human history as the only infectious disease ever eradicated. Its defeat was a result of a massive coordinated global campaign led by the World Health Organization. The last naturally occurring case was recorded in Somalia in 1977. Today, smallpox exists in only a handful of secure laboratories. A reminder of both the devastation it once caused, killing an estimated 300 million people in the 20th century alone, and the extraordinary power of science and international cooperation.
And now there's fears that it could come back to the United States. So measles is just one of a lot of possibilities of what's out there. And they're scary things that we have protections for. Smallpox is one that we have eradicated in the wild. But of all the viruses on Earth, that's one of the scariest ones to me because that has killed more humans than any other pathogen that we're aware of in human history.
Wow.
In fact, when we tried to eradicate smallpox, it was an effort where we actually worked with the Soviet Union. Despite the Cold War, we partnered with the Soviet Union to get rid of this thing. That's how bad it was. Nobody wanted it. Them, us, everybody. It was a worldwide effort because it's believed that this thing has killed 2 billion humans in the history of humankind.
That's like inconceivable.
And everybody used to get it, and you have a 30% chance of dying from it. I mean, it was horrible. So there's a lot of these viruses, like it's hard to answer the question of which one am I most worried about. Because if something were to happen and a virus were to jump and we don't have the protections or we're not willing to embrace the science in trying to deal with it, like avian flu, which we keep hearing news about, right? There's a lot of concerns out there for what could happen. And again, I sound like an alarmist, but the question is, what does the future look like? We got a lot of great things we can do today. Science and medicine are really, really strong. But is our society ready for the advances that might come from it?
From the microscopic world of viruses to the sweeping impact of pandemics, the story of infectious disease is far from over. Science offers powerful tools, but it's up to us to use them wisely. Coming up next, we're diving into one of the most important and hotly debated topics in public health: vaccines. Discover how immunization has transformed the fight against deadly viruses and why the story doesn't end there. We'll also unravel the surprising history of the anti-vaccine movement and how misinformation in this context can spread faster than any viruses, underscoring the importance of how public perception matters. This show was edited by me, Gordon Thane, with additional editing from LaShawn Benedict. Sound design and mixing by myself and LaShawn Benedict. The original music from The Music Room, composed by Tom Fox, licensed from Johnny Harris. The cover art designed for our show by LaShawn Benedict. The Public Health Insight Podcast is produced by PHI Media. Thank you for listening to the Public Health Insight Podcast, your go-to space for informative conversations, inspiring community action. If you enjoy our podcast, be sure to subscribe and leave us a rating on Apple Podcasts or Spotify. See you in the next one.